So whenever we look for these interactions and feedbacks which have lead-lag relations, we always worry about or look for whether there is a way to use the lead lags and the coupling and the feedbacks for making predictions, right? So we'll just run through couple of examples of how the forecasting can be done for the tropics based on, let's say, the NAO phase, and for the NAO based on the MJO phase, and so on. From this nice paper, I took this figure which is showing the negative and positive phases of NAO, which probably many of you know. The Icelandic low and the Azores high oscillate back and forth, which affects the direction of flow and the storms and the rain and the snow onto parts of Europe, northern and southern Europe, depending on the phase. Then there is the Atlantic ridge and the Scandinavian blocking pattern. These are the centroids of 4 weather regimes obtained from daily anomalous geopotential height at 500 hectopascal altitude from the national, so that's the NCEP NCAR reanalysis. Each percentage corresponds to the stated number of days and represents the mean frequency of occurrence of the regime computed over 1974 to 2007 for the MJO season, so 1st November to 31st March, approximately winter, let's say. Okay, so you can see the various percentages here and corresponding to the frequencies of these patterns, which we don't need to worry about the details, but mainly I want to say that we can again look at the systematic eastward propagation of the MJO, so phase 1 to up to 8. So the OLR anomalies in color, they show that when it is negative, that's obviously a convective phase, because deep convection, colder temperatures reduce the OLR, and the dry phase has the positive OLR anomalies at intraseasonal time scale. And you can see the signatures ahead here, which often can be other features that are being filtered into MJO depending on how you did it. There is phase 2, but shown along with these MJO phases 1 to 8 are the streamlines on the 300 hectopascal geopotential height, and you can see that obviously there are coherent mid-latitude extratropical signatures with each phase of the MJO, which is not anything new, we have already said it. And of course there is also this kind of a cross-equatorial link coming through the in phase 8, and there is a southern hemisphere signature as well associated with the MJO phases. Okay, so this is what has allowed us to keep talking about this tropical extratropical interactions, coupling and feedbacks. So what do we do with it? There have been some nice papers that looked at predictions, actual forecasts of NAO and MJO at intraseasonal timescale. To come back to our focus here, which is the intraseasonal timescale, we already said that MJO affects the phasing of the NAO, and then NAO can feed back to the MJO. So it would be nice to see how MJO phase affects the NAO forecast and how NAO affects the MJO forecast, right? So this is the Canadian forecast system, which is the full model, and it beats persistence up to 6 pentads, so you can see that the GEM forecast is above persistence, which is kind of a minimal level of skill you would want to look for. If you just persist 1 pentad to the next, what would be the correlation? It's kind of an autocorrelation kind of thing. The model that's doing a forecasting better be better than persistence, right, to have any skill at all. So obviously it does well, and of course the skill drops off as you go into longer and longer lead times, which is expected. But now you look at the NAO forecast skill for the same pentads, but this is the ensemble mean from the model forecasts. You look at weak MJOs, 106 cases, strong MJOs, 254 cases, and generally weak and strong MJOs here. So again, you can see that the NAO forecast skill is better for a so that's the persistence there as well. Oh, sorry, the ensemble spread, and you can see that the skill is higher for strong MJO cases, and it is weaker for weak MJO cases. So the strength of the heating, we have already said how the position of the heating as it moves eastward matters as well, and the strength of the MJO also matters. You can look at it in terms of the RMM index that we looked at. Also can be looked at as precipitation intensity, OLR, and so on and so forth. So the basic point I would want to leave is that NAO does have a forecast skill. NAO is forecastable at a few pentads, and its forecast skill depends on the strength of the MJOs because of the teleconnections from the MJO to the NAO. How about the other way? So if you look at MJO forecast skill again from the same system, again it beats persistence. Now we are in days, but obviously pentad 1 to 6 again. And MJO skill by initial NAO amplitude. For weak NAO, this forecast skill drops off much faster, even though there is some kind of a recovery here which has to be understood, but you can see the error bar is quite high as well. But for strong NAO, you can see that the skill is higher after pentad 2. So in the beginning they are both the same. This is the initial NAO amplitude, and after pentad 2 out to about 5.5 pentads, the strong NAO produces better MJOs. The other point we have to confirm is that since MJO is a heat source, and that is what gives it the ability to generate Rossby waves which can go into the extratropics and affect things like the monsoons and NAO and PNA and so on. What is the impact of the heating on the predictions? So this is Matt Newman's nice work using a linear inverse model where the observational low frequency and noise kind of stochastic forcing are used to look for forecast skills. So this is the expected skill of infinite ensemble during winter, which means you can do randomly high number of ensemble members. It's a simple model, so easy to run. So the linear inverse model skill in days again for the mid-latitude flow patterns. So this is, you can think of this as the NAO forecast based on tropical forcing. So the skill is good according to the LIM out to 6 pentads, but if you remove the feedbacks from the tropical forcing, which is essentially the tropical heating, then the skill drops off. So there are other papers which have argued that the role of the tropical heating is very critical for prediction skill of the extratropical features that are related to MJO, which is obvious, but yet it's important to confirm that. So this is expected skill of infinite ensemble during summer. This is during winter. In both seasons, the skill is lower if you remove the tropical forcing from the extratropical flow patterns that you are trying to predict. Okay, so that's a cute little story of how the extratropical tropical interactions, feedbacks and coupling, and the lead lag relations can be used to make forecasts, which is obviously very useful for atmospheric rivers, for European weather, and so on. And many of the models have the skill to capture this relation, even though there are always biases, and then there are methods to correct the biases in the models to improve the skill. There is either bias correction done before forecast, or there is post-processed bias correction and so on, but we won't get into those details. I have a course on S2S subseasonal to seasonal forecasting on my channel, which you can look up to for additional points about forecasting at interseasonal timescales. Here we are more specifically focusing on the tropical extratropical interactions and their impacts on the subseasonal forecast here. Okay.